Good day viewers, you're welcome back to my channel. Today we have the following limit problem. Limit as x is approaching 0, x minus the sine function of s all over s cubed is equal to 1 all over 6. We are asked to prove the closed form of this limit. Okay, now we are asked in this limit not to use the L'Hopital's rule. By the way, if you want to use the L'Hopital's rule, we're going to differentiate three good times, the numerator and denominator here, and we're going to get this value. But recession is there, we are asked not to use it. So how do we solve this problem? Remember that direct substitution gives 0 all over 0, and that is in indeterminate form, which is not allowed in mathematics. Okay, now one of the famous ways to solve this problem should be to use the maclaurine series expansion of this function here. So let's start by sine function of x, which is given as x minus s cubed all over 3 factorial plus x raised to the power 5 all over 5 factorial minus x raised to the power 6 all over 6 factorial plus all the way to infinity. Okay, now from here we have x minus the sine function of x to be equal to x minus, in bracket, x minus s cubed all over 3 factorial plus x raised to the power 5 all over 5 factorial minus x raised to the power 6 all over 6 factorial plus, and so on. Okay, now simplifying this bracket, so we have here x minus x here is 0. Okay, we're using this negative sign to open up this bracket, so the signs here changes. So we have this equal to s cubed all over 3 factorial minus x raised to the power 5 all over 5 factorial plus x raised to the power 6 all over 6 factorial minus, and so on. Okay, and this is what? X minus the sine function of x. So we're going to divide both sides by x, okay, so that we can get exactly the function in this limit. Okay, so dividing both sides by x, so we get this all over x. Dividing both sides by s cubed, so that we get exactly what is given, the function here. So we're dividing both sides by s cubed, so this is all over s cubed. Okay, now we have x minus the sine function of x all over s cubed to be equal to, splitting this denominator, s cubed over 3 factorial divided by s cubed, so s cubed gets cancelled out from up and down, so we are left with what? 1 all over 3 factorial minus, x raised to the power 5 over 5 factorial divided by s cubed. S cubed reduces this to what? X squared all over 5 factorial, then s cubed all over 6 factorial minus, and so on. Okay, now we have that the limit as x is approaching 0 of this function x minus the sine function of x all over s cubed is the same as what? Is the same as limit as x is approaching 0 of this series 1 all over 3 factorial minus s squared all over 5 factorial plus s cubed all over 6 factorial minus, and so on. Okay, now 1 all over 3 factorial as x is approaching 0 is just 1 all over 3 factorial. Okay, minus x squared over 5 factorial as x is approaching 0 is 0 plus s cubed over 6 factorial as x is approaching 0 is 0 minus 0 plus 0, and so on. And this is exactly equal to 1 all over 3 factorial, and this is equal to 1 all over 3 times 2 times 1, and that is equal to what? 1 all over 6. Thus we prove the limit. Thank you for viewing, and please make sure you subscribe to my YouTube channel for more interesting videos.